also. The next question is the solution of nickel sulfate in which nickel rod is dipped is diluted 10 times, then potential of the nickel. Now what will happen to the potential of the electrode depends upon the concentration. For nickel electrode, the reaction can be written as nickel plus 2 giving rise to nickel, and potential of the nickel rod will be like this: E naught value plus 0.059 by N log C. What is C stands for? The concentration of the electrolyte. What is C stands for? Concentration of the electrolyte. What is N stands for? What is the N stands for? Number of the electrons involved. Now what is given in the new problem? The concentration is reduced to 1 by 10. The concentration is reduced to 1 by 10. Then E naught, for this we can practically take it as 0.06 into 2, and since the concentration is diluted by 10 times, what will be the E cell now? E naught of the electrode will be E naught minus 0.03 volts. Converting, that is, what does it imply? The potential of the electrode decreases by 0.03 volts. When it converted into millivolts, 0.03 into 1000 millivolts, it comes to 30. It comes to 30 millivolts. Next, option 3 is the answer. Now what is the question? The standard EMF is that, what is the EMF for the cell reaction when 0.1 molar Cu plus 2 and 0.1 molar Zn plus 2 are taken? What is the cell reaction here? Zn plus Cu plus 2 gives rise to Zn plus Cu plus 2 gives rise to Zn plus 2 plus Cu. What will be the reaction coefficient here? Zn plus 2 by Cu plus 2. Now E cell is equal to E naught of the cell minus 0.059 by N 2 electrons log Zn plus 2 by Cu plus 2. What is Zn plus 2 concentration? Zn plus 2 concentration is given as 0.1 and Cu plus 2 concentration is also given as 0.1. This term becomes 0. Then E cell will be equal to E naught of the cell. E cell will be equal to the E naught of the cell. So that is 1.1 volts. Option 1 is the answer. Next question. Through 3 Faradays of electricity are passed through the molten Al2O3 aqueous solution of aqueous solution of CSO4 and molten NaCl. Then what will be the products we get at the cathodes? Aluminium, copper and sodium. For 3 Faradays of electricity, what will be the number of equivalents? We get 3, 3, 3. What will be the number of the moles? We get. How do you get number of the moles? Number of equivalents by valency. 3 by 3. For copper, valency is 2. For sodium, valency is 1. 1.5, 3. So option is 2. So what is the valency? Number of electrons required for the deposition of 1 mole of the element at the respective electrode is called valency. For aluminum requires 3 electrons, Copper requires 2 electrons, sodium requires 1. That is why their valencies are 3 to 1. Next question. 965 amperes of current is passed through the for 1 minute and 40 seconds time. The mass of the metal deposited is 9 grams at the cathode. What is the valency of the metal atom? Atomic weight is 27. So by definition valency is equal to atomic weight by equivalent weight. So from our expression W is equal to E by F CT, we can find the E value. What is W value? 9. What is the W value? 9. What is the equivalent weight? We have to find 96,500. And what is C? 965 amperes. What is T in seconds? 100 seconds. So E is equal to 9. Valence is equal to 27 by 9, 3. Answer 2. Option 2 is the answer. Next question. What is the time required for depositing all the silver present in 125 ml of 1 molar AgNO3 solution by passing a current of 241.25 amperes? W is equal to E by F CT. What is E here for silver? What is the time for silver? Equivalent weight for silver is 108. And what is the C value? Current strength of the current in amperes? 241.25. What is the mass? How do you get weight of the silver? Molarity into molecular weight into volume in ml by 1000. So since for silver, instead of molecular weight, we will write the atomic weight. What is the molarity given? 1 and 108. What is the volume? 125 ml. 125 ml by 1000. This is the weight. Substitute here. W is equal to 108 into 125 by 1000. Equivalent weight is equal to 108. This is 96,500 and this is 241.25 into T. This 108 gets cancelled out. This is 8 times. This is 400 times. So T will be approximately 50 minutes. T is equal to 50 seconds time. Option 2 is the answer. Next question. 6 into 10 to the power of 22 electrons will be equivalent to 0.1 Faraday, because 6 into 10 to the power of 23 electrons, 6 into 10 to the power of 23 electrons is equal to 1 equivalent weight. 6 into 10 to the power of 22 electrons will be equal to 0.1 equivalent. So 0.1 equivalent is equal to 1.9 grams. 1 equivalent is 19 grams. So as usual, valency is equal to atomic weight by equivalent weight. 57 by 19, it is equal to 3. Option 2 is the answer. The density of the copper is number of coulombs required to plate an area of 10 into 10 centimeters of thickness 10 to the power of -2 using copper sulfate solution as the electrolyte. Here what we have to find? W is equal to E by F Q. So we have to find the Q value. Now what is W? Volume into density, volume into density. How do you get volume? Area into thickness. Mass is equal to volume into density, which is equal to area into thickness into density. Area into thickness into density. What is the area? 100, 10 square into 10 square. What is the thickness? What is the thickness? 10 to the power minus 2. Oh, sorry. This is 10 and 10. 10 and 10. And this is 10 to the power minus 2. What is the density? 8. What is the density? 8. Now, what is 8 by weight is equal to 8. What is the equivalent weight of the copper? So, can be taken as 32. It can be taken as 32. 96,500. 96,500 into Q. So, simplifying it, Q will be equal to 24,125 coulombs. The mass is 8 grams. Mass is 8 grams. Option 2 is the answer. Next. This is simple. This is simple. What is the for same quantity of electricity, weight of hydrogen by weight of mass of hydrogen obtained is x times that of the oxygen. X times of that of the oxygen. Weight of hydrogen by weight of oxygen will be equal to, for the same quantity of electricity, for the same quantity of electricity, for the same quantity of electricity, weight of hydrogen by weight of hydrogen by weight of oxygen will be equal to equivalent weight of the hydrogen by equivalent weight of the oxygen, which is equal to 1 by 8, which is equal to 1 by 8. So, weight of hydrogen is equal to weight of oxygen into 1 by 8 implies x is equal to 1 by 8. X is equal to 1 by 8. Now, next what is the other thing? Volume of the hydrogen by volume of the oxygen will be equal to gram equivalent volume of the hydrogen, gram equivalent volume of the hydrogen by gram equivalent volume of the oxygen, which is equal to 11.2 by 5.6. This is equal to 2. This is equal to 2. This is y. This is y. Now, y by x is equal to 2 by 1 by 8, that is equal to 16:1. Option 1 is the answer. Weight of hydrogen. Weights are proportional to equivalent weights. Volumes are proportional to gram equivalent volumes. This is the way to solve. Next question. When aqueous solution of sodium acetate is electrolyzed, 22.4 liters of ethane is liberated at the STP at the anode. The number of coulombs of electricity passed is, now what is the equation? 2CH3COONA, 2CH3COONA plus 2H2O gives us to C2H6 plus 2CO2. These gases are obtained at the anode plus hydrogen at the cathode, and NaOH will be obtained in the solution. NaOH will be obtained in the solution. Now, what is the reaction at the anode? At anode, 2CH3COO minus 2CH3COO minus will give rise to C2H6 plus 2CO2 plus 2 electrons. So, for 1 mole of ethane, how many electrons are required? To get 1 mole of ethane, how many moles of electrons are required? Or 1 mole, how many moles of electrons are required? 2 moles of electrons. That is for 22.4 liters. For 22.4 liters, how much current will be required? 2 into 96,500 coulombs. Because 1 mole of electrons is equivalent to 96,500 coulombs. 2 for 2 moles, how many electrons will be required? 2 into 96,500 coulombs. Because for the production of 1 mole of ethane, how many moles of electrons are needed? 2 moles of electrons. 1 mole means 22.4 liters at STP. For the production of 22.4 liters of ethane at STP, how many moles of electrons? 2 moles of electrons, that is 2 faradays of electricity is required. Option 2 is the answer. The number of faradays of electricity required to decompose 100 ml of water. 100 ml of water means 99 grams of water, because density is given as 0.99. Density is given as 0.99. How many equivalents? That is number of equivalents. Number of equivalents is equal to 99 by 9. 11 equivalents means how many faradays? 11 faradays. 11 equivalents means 11 faradays of electricity. That is option 2 is the answer. Now 3 faradays of electricity. AgNO3, CuSO4, AgNO3. What are the metals we get? Silver, copper, gold. Silver, copper, gold. For 3 faradays of electricity, number of equivalents will be 3, 3, 3. So what will be the number of the moles? In terms of the moles, number of moles will be 3 by 1, 3 by 1, 3 by 2, 3 by 3, 3 by 3. Now simplifying it, this is 1. This is simplifying it, it will be 6 is to AgNO3, CuSO4, gold, 3 by 3. So multiplying with 6, it will be 6 is to 3 is to 2, 3, 1.5, 1. It will be 6 is to 3 is to 2. The ratio is 6 is to 3 is to 2. Option 4 is the answer. Next, the specific conductance of 0.1 molar solution is 0.012. The resistance is 55. By definition, specific conductance is equal to 1 by R into L by A. 1 by R into L by A. So the resistance is given as 55. L by A is equal to K into R. What is K? 0.012. And what is resistance? 55. So option is the 2. Next question. So we'll do this in a peacefully. This is a two-step problem. This problem will be useful for those students who are appearing for the NEET. And in our yesterday's class, I told you one point: how to get conductivity in MKS systems. In MKS system, lambda m is equal to K by 1000 into molarity. K by 1000 into molarity. Here the problem is given in 2 steps. In step 1, what we have to do? We have to calculate the cell constant. Calculation of the cell constant. Because they have given us the K value. K is equal to 1 by R into L by A. 1 by R into L by A. So L by A is equal to K into R. K into R. What is K in the first equation? In the first equation, K is equal to 1.29 and R is equal to 100. 1.295 into 100. So 129.5. 129.5. This is the cell constant value. So what from the information given in the first part of the problem, what is the how we can use the information given in the first part? The information given in the first part of the problem can be used to calculate the cell constant, because in the step 2, what is the lambda m is equal to K by 1000 into m. K by 1000 into m. Here molarity is equal to 0.02. What is to be found out? K. K is equal to 1 by R into L by A into L by A. What is R value here? 520. What is R value here? 520. What is the cell constant value? 129.5. 129.5. So approximately the value comes to 1 by 4, that is 0.25. So K value comes to 0.25. Now what will be the molar conductivity? K is equal to 0.25 by 1000 into 0.02. Simplifying it, will get the option 2 as the answer. So the information given in the first part of the problem can be utilized to calculate the cell constant. From the information given in the second part, we calculate the specific conductivity and substitute in this expression. In MK system, the how to find that this 1000 will get into the denominator. Remember this. Next, lambda naught of NH4 at infinite dilution is to be found out. What is given? What is given? Lambda naught of NH4OH, lambda infinity of NH4OH can be calculated from the, this is a direct application of the Kohlrausch law. Lambda infinity of NH4Cl plus lambda infinity of OH minus lambda infinity of Cl. From this, what is lambda infinity of NH4Cl? 130 plus what is the lambda of OH? 174, and what is this? 66. So it comes around 238. 304 minus 66 will be 238. Option 3 is the answer. Option 3 is the answer. Next question. Here, what is the, how to find the solubility product? How to find the solubility product? Solubility product, for to calculate the solubility, S is equal to 1000 into K by molarity. 1000 into K by molar conductivity. Because how to get molar conductivity? Molar conductivity is equal to 1000 into K by molarity. For in case of sparingly soluble salts, molarity will be equal to S. So lambda m will be equal to 1000 into K by S. S will be equal to 1000 into K by lambda m. Now they have given us the equivalent conductance. How to get lambda m value? Lambda m value is equal to lambda equivalent multiplied by n factor. Lambda equivalent by multiplied by n factor. What is the n factor for barium sulfate? 2. For barium sulfate, what is the n factor? 2. Therefore lambda m will be equal to 400 into 2, 800. 400 into 2, 800. What is the K value? 8 into 10 to the power minus 5. Therefore, S is equal to 1000 into, what is K value? 8 into 10 to the power minus 5 by 800. So, S will be equal to 10 to the power minus 5. KSP value for barium sulfate is equal to, will be equal to S square, that is 10 to the power minus 8. 10 to the power minus 8. Option 2 is the answer. A quantity of electrical charge that brings about the deposition of 4.5 grams of the aluminum at the cathode will also produce the following volume of STP. This is simple one. Number of equivalents for the same quantity of electricity, number of equivalents of aluminum is equal to number of equivalents of hydrogen. For this, weight by equivalent weight. For this, volume by gram equivalent volume. What is the weight? 4.5. What is the equivalent weight of aluminum? 9. So we are supposed to calculate the volume. What is the gram equivalent volume of the hydrogen? 11.2 liters. So we will be equal to 5.6 liters. Option 4 is the answer. Next, here cost of the electricity is always inversely proportional to the equivalent weight. Cost of electricity is always inversely proportional to the equivalent weight, because to produce 1 gram equivalent of hydrogen, 1 Faraday is required. So to produce 1 gram with 1 Faraday, we can produce 1 gram equivalent weight of hydrogen, that is 1 gram. Whereas to produce 1 gram equivalent weight of silver, that is 108 grams, we need only 1 Faraday. That is 108, production of 108 grams of the silver and production of 1 gram of the hydrogen will incur the same cost. This is 1 gram, this is 108 grams. To produce same quantity of the silver, hydrogen, 108 grams of the hydrogen, we need to spend 108 Faradays of electricity. So cost of electricity is definitely inversely proportional to the equivalent weight. Cost of electricity is inversely proportional to the equivalent weight. Now, what are the substances involved here? Hydrogen and oxygen. Now, cost for hydrogen by cost for oxygen. Cost for oxygen is inversely proportional to the equivalent weight of the oxygen by equivalent weight of the hydrogen. Equivalent weight of the hydrogen, or equivalent volume of the, here volume is given, equivalent volume of the oxygen by equivalent volume of, this is equal to 1 by 2. This is in terms of the volumes, equivalent volume of the oxygen by equivalent volume of the hydrogen. What is this ratio? It will be 5.6 liters by 11.2 liters, 1 by 2. 1 by 2 cost of electricity produced will be, now what will be the cost to produce oxygen, 2 into cost of hydrogen, that is equal to 2x, because here weights are under volumes are under consideration, right? The value of the reaction coefficient in the given this reaction. What is the reaction there? At anode, Zn gives us to Zn plus 2. At cathode, 2Ag plus 2 electrons gives us to 2Az. Therefore, what is the reaction? Zn plus 2Ag plus gives us to Zn plus 2 plus 2Az. So reaction coefficient Q will be equal to concentration of Zn plus 2 by Ag plus concentration. What is Zn plus 2 concentration given? 0.01. What is Ag plus concentration? 1.25 and 1.25. Simplifying it, we will get the answer as 6.4 into 10 to the power minus 3. Option 3 is the answer. Next question. See what is given there. E cell will be equal to E naught of the cell minus 0.06 by 2 log Zn plus 2 by Cu plus 2. Log Zn plus 2 concentration by Cu plus 2 concentration. So what is given here? E cell minus E naught of the cell must be equal to minus 0.12 volts. This can happen when log Zn plus 2 by Cu plus 2 happens to be the 4. The value must be equal to 4. Log Zn plus 2 by log or Zn plus 2 by this value must be equated to the 4. That can happen in the option 3 when Zn plus 2 concentration by Cu plus 2 concentration is equal to 10 to the power 4. What will happen? That can happen only in the option 3, because E cell is equal to E naught of the cell minus 0.06 by 2 into log Zn plus 2 by Cu plus 2. If it happens to be 10 to the power 4, it happens to be the 10 to the power 4. What will happen? E cell will be equal to E naught of the cell minus 0.012. Only this value is equal to 4, then only we can get this value. That can happen only option 3 occurs. Next one. What is the considering the reduction reaction of hydrogen H plus electron gives us to of H2. Now what is the cell reaction here? E of hydrogen electrode is equal to E naught of hydrogen minus 0.059 by 1 into log 1 by H plus. Since E naught of hydrogen is equal to 0. Standard potential is taken as a 0 minus 0.059. And what is log 1 by H plus? Nothing but a pH. So potential of the hydrogen electrode in terms of pH value is 0.059 pH. Option 4 is the answer. Next. In this case, there can be more than one correct option. What is the cell EMF of in which cell reaction is Cr2O7 plus can be increased by the now coming to the reaction coefficient. What is, how do you write EMF for the cell? E cell is equal to E naught of the cell minus 0.059 by n, 0.059 by n, and what will be the log Cr plus 3, log Cr plus 3, Fe plus 3 taken 6 times by Cr plus 3 taken 2 times by Cr2O7 minus 2, Cr2O7 minus 2, Cr2 minus O7 2, H plus taken 14 times, So the cell EMF can be increased, by decreasing if you decrease this value, this fraction decreases, this value decreases, total EMF for the cell increases. By decreasing the pH value means by increasing the H plus ion concentration also, this negative value can be decreased, therefore EMF for the cell can increase. So to increase the value, what should be done? The negative value of this portion must be decreased. That can happen by decreasing the Fe plus 3 concentration or by increasing the H plus ion concentration. When you increase the H plus ion concentration, what does it imply? Decreasing the pH value. In this question, there are two correct options, 2 and 4. Intentionally we have given this question because more options can be verified. Lambda m, lambda e must be equal, lambda mm and lambda e must be equal. That can happen only when n factor is 1. When molar conductivity and equivalent conductivity will be equal, when the n factor is 1, that happens in the case of the KCl, So option 2 is the answer. This is a typical question which is given in the many national wide examinations, here. What is the point here? Here they have given the delta G value. They are asking EMF. What is the relation between delta G and EMF? Delta G is equal to minus NFE. This is the relation between change in free energy and EMF for the cell. How do you find EMF for the cell? E cell will be equal to delta G by minus NF. What is delta G? Minus 827 kilojoules into 1000 joules by what is the F? 96,500. We have to find N value. What is nothing but what is N? How to calculate the N value? What do you mean by N value? Number of electrons involved, which can be obtained by the change in the oxidation number. 4 by 3 Al, 4 by 3 Al is giving rise to Al2O3. What is the change in the oxidation number? Here plus 3, here 0. So therefore change in the oxidation number is equal to 3 minus 0 into 4 by 3, which is equal to 4. So n value is equal to, therefore n value is equal to 4. Now substituting in the above expression, E will be equal to 827,000 by 4 into 96,500. E will be equal to 2.14 volts. 2.14 volts. Next question. The equilibrium constant Kc will be equated to Q. So equilibrium reaction coefficient will become equal to the equilibrium constant. Reaction coefficient will become equal to the equilibrium constant only at the when the process is at a equilibrium. Kc can be equal to Q when the process has attained equilibrium. When the process has attained equilibrium, at equilibrium E cell will be equal to 0. At equilibrium E cell will be equal to 0. This can happen only when the process attains equilibrium. When the process attains equilibrium, E cell will be equal to 0. That is option 3 is the answer. See here what is to be done here. We are asked to calculate the equilibrium constant. Equilibrium constant. What is the expression? E cell is equal to E naught of the cell minus 0.059 by n log Q. At equilibrium, E cell will be equal to 0 and Q will be equal to Kc. Then the expression will be equal to E naught of the cell will be equal to 0.059 by n log Kc. Now log Kc is equal to Ne naught of the cell by 0.059. This is the way I have to calculate the equilibrium constant. In case of Zn plus 2, what will be the E naught value? E naught for this equilibrium, what will be the E naught value? 1.1 electron volts. 1.1 electron volts. This is a galvanic cell. In this, what will be the E naught value? 1.1. And what is this value? This value 2. Number of electrons is 2. 2 into 1.1 by 0.059. So simplifying it, we get log Kc will be equal to 10 to the power of 2.2 by 0.059, which is equal to 10 to the power of 37. This is the way of getting the equilibrium constant. Next, how much time is required for the complete decomposition of 4 moles of water using a current of 4 amperes? 4 moles of water means 4 into 18. What is the simple formula? W is equal to E by F Ct. 4 into 18. What is the equivalent weight of water? 96,500 into 4 into T. So solving, we get T as 1.93 into 10 to the power of 5 seconds. Okay. 2, 4 gets cancelled out. T is equal to 2 into 96,500 seconds. Next question. Option 1 is the answer. Next. How many Faradays are required to obtain 1000 grams of the sodium perchlorate? So simple logic is W by E is equal to Q by F. W is equal to E by F CT. This is simplified as W by E is equal to Q by F. Now what is W? 1000 grams. 1000 grams. What is the equivalent weight? Molecular weight by change in oxidation number. Molecular weight by change in oxidation number. How do you get change in oxidation number? NaCl is getting converted into NaClO4. What is the oxygen state here? +7. What is the oxygen state here? -7. Change in oxidation number is equal to 8. What is the molecular weight of the sodium perchlorate? 23. Molecular weight of the sodium chloride. Molecular weight of the sodium perchlorate is 23 plus 35.5 plus 64. 58.5 plus 64. 122.5. 122.5. So 122.5 by 122.5 by 8. 122.5 by 8. This is the equivalent weight. This is the equivalent weight of the chlorine. Molecular weight by 8. Now coming back to this, what is W? 1000. What is the equivalent weight? 122.5 by 8. Q we have to find 96,500. 96,500. Roughly we get 66 Faradays. Q will be equal to 66 Faradays. 66 Faradays. Solving it. This is Faraday. This becomes 66. Option 1 is the answer. This is dilute H2SO4. Option 4 is the answer here. Because on electrolysis, which of the following does not give out oxygen? Option 4, because in option 4 we are using the active electrodes. When active electrodes are employed, what will happen? What will be the reaction at the anode? Copper gets dissolved and goes into the solution in the form of copper ions. These copper ions reach the electrode to give copper. So what will happen? Entire anode metal gets dissolved due to oxidation and get deposited on the cathode. So in option 4 we don't get oxygen. It's not option 3. Next. Here, how do you get amperes? Watt by volt will give us the amperes. Strength of the current in amperes is equal to wattage by voltage. That will be equal to 110 by 110 is equal to 1. What mass of cadmium will be deposited by the current flow for 10 hours time? So W is equal to E by F CT. What is the equivalent weight of the cadmium? Atomic weight by 2. So 112.4 by 2. 112.4 by 2, that is 56.2. So W is equal to 56.2 by 96,500. And what is C here? Cadmium will be deposited by the current flow for so what is C here? C is equal to 1 and 10 hours, 10 into 60 into 60. This is the mass. Next, so usual this first law of Faraday, W is equal to A by F CT, W is equal to A by F CT, or we can simply write it as W by E is equal to Q by F. Q by F. Q by F. Now, what is the equivalent in the reduction of the nitrobenzene C6H5 NO2 plus 6H gives us to C6H5 NH2. So, how many protons are involved here? 6 protons. So, what will be the N factor? 6. So, equivalent weight of nitrobenzene, equivalent weight of the nitrobenzene will be equal to molecular weight by 6, that is 123 by 6. Now, here the current is not working at the full efficiency. What is the weight given? 12.3 and by 123 by 6, 123 by 6. Now current is not working at full efficiency, so Q must be taken as 50 by 100 into Q by F. So what is this on this side? 0.6, on this side 0.6, it is equal to 0.5 Q by F. So Q, so 0.5 Q will be equal to 0.5 Q will be equal to 0.6 Faradays. Q will be equal to 1.2 Faradays. 1.2 Faradays. Option 1 is the answer. Option 1 is the answer, because what is the point we have to take here? Current is not working at a full efficiency, it is working at a 50% efficiency. So, whatever when you apply this principle, so must take the efficiency of the current also into consideration. Since it is working at a full of efficiency, I have taken it as 50 by 100. So, 0.5 Q will be equal to 0.6 Faraday, Q will be equal to 1.2 Faraday, 1.2 into 96,500, 96,500, it comes around 1,58,000 coulombs. Next. So, in this lead storage battery, what is the complete equation? Pb plus PbO2 plus PbO2 plus 2H2SO4 will give rise to 2BSO4, 2PbSO4 plus 2H2O. In this lead storage battery, how many electrons are involved? 2 electrons. So what will be the N factor for sulfuric acid in lead storage cell? N factor for sulfuric acid in lead storage battery cell will be equal to 1, because for 2 moles for the consumption of 2 moles of sulfuric acid, how many moles of electrons are involved? 2 moles of electrons are involved. So what is the N factor for sulfuric acid in lead storage battery? 1. So in lead storage battery, molarity of H2SO4 must be equal to normality of H2SO4. Now what is done? Initial number of the equivalents taken, number of equivalents, initial number of equivalents of H2SO4 present, initial number of equivalents of H2SO4 present, 1.5 into 5, 1.5 into 5, which is equal to 7.5 equivalents, 7.5 equivalents, or you can take it as in this case number of equivalents is equal to number of the moles. What will be the concentration of H2SO4 after 2.5 amperes of current is drawn from the battery for 6 hours? So, number of equivalents of H2SO4 consumed, number of equivalents of H2SO4 consumed, number of equivalents of H2SO4 consumed will be equal to quantity of the electricity, will be equal to the quantity of the electricity passed in Faradays, What is the quantity of the electricity in Faradays? So, Q is equal to 2.5 into 6 hours, 6 into 60 into 60, 60 into 60. This comes around approximately 0.5, 15 into 3600, 600. So, approximately 0.5 Faradays, approximately 0.6 Faradays. What is the Q? 0.6 Faradays. So, how many equivalents are consumed? 0.6 equivalents consumed. So, final quantity of H2SO4 left out, final quantity of H2SO4 left out is equal to 7.5 minus 0.6, 6.9 equivalents, 6.9 equivalents, or it can be equal to 6.9 liter moles, because in this n factor is equal to 1. So, final concentration of H2SO4, will be equal to 6.9 number of moles by volume in liters. Number of moles by volume in liters. It is option 1. Assuming no change in the volume, the time required to attain a solution of pH 12 by electrolysis of 50 ml of 0.1 molar NaCl using current of 0.5 amperes will be. Now, pH 12 means when aqueous NaCl solution, is electrolyzed, we get NaOH. pH is 12 implies pOH is equal to 2. That is OH minus 1 concentration. OH minus 1 concentration is equal to 10 to the power of minus 2. Now, what is the weight of NaOH formed? Weight of NaOH formed is equal to weight of NaOH to be formed is equal to 10 to the power of minus 2 into 40 by 50 by 1000. This is weight. 10 to the power of minus 2 into 40 into 50 by 1000 ml is equal to what is E? 40 by 96,500. And what is the C value? C value is 0.5 amperes. From this we can find T value. That is, it is coming to 96 0.440, and this 40 is getting cancelled out, and simplifying it, it will be T is equal to 96.5 seconds. We will continue in the next class.